Okay, 5.3. We are proving triangles congruence by SAS. Some SAS. Okay? SAS is side, angle, side. Okay, so just so you know, SAS stands for side, angle, side. SAS. Okay? Let's get started. Let's get started with this lesson. I'm excited. All right, here we go. This exploration you guys can do if you'd like. What it's saying, what this example or explanation is saying is we have point A, B, and C. And A is at a 40-degree angle. We're not going to change that. What they want you to do is find the lengths of AB and AC. Okay, so you find the lengths, and then after that, they want you to move B anywhere along that inner circle. So they could put B right here, but 40 degrees stays the same, and C like over here, whatever it may be, so that we come up with our new angle. And they ask, is it congruent to that first triangle? The answer is yes, because all we're doing is rotating. And remember, with translation or transformations, rotations have rigid motion, right? Angles and side lengths, they all stay the same. So yeah, they're going to be equal. All right, here we go. So you guys can do this if you'd like. They give you a whole list of things. I'm going to start with question number 2 here. What can you conclude about two triangles when you know that two pairs of corresponding sides and the corresponding included angles are congruent? Okay, so if we have a triangle right there, right, and we know that this is a B, C, I just made a triangle. Okay, and then we have another triangle. And imagine these are congruent. Okay, we have D, E, and F. Let's say angle A and angle D are congruent. Okay, so angle A is congruent to angle D. And then let's say AB is congruent to DF, or DE, sorry. So AB is congruent to DE. And lastly, let's say AC is congruent to DF. Okay, that's what question 2 is asking. What can you conclude about two triangles when you know that two pairs of corresponding sides and the corresponding included angles are congruent? Right? The included angle is in between those two congruent sides. Well, if we know that we have two side lengths and an angle that will not change, no matter what, this last green side, has to be congruent. It has to be. And these angles have to be the same. They have to be. Okay? Try to construct a triangle that has two side lengths that are the same, or corresponding side lengths are the same, two sets with that included angle being the same, and try to construct another triangle with a different third side. You can't. It's not possible. Okay? Those two triangles have to be congruent. All right, so that is our conclusion, is that when we have two pairs of corresponding sides and the corresponding included angle congruent, then the triangles are congruent. 3, again, that's with the exploration. I'm not going to do that. Move on to notes here. Congruent figures. Congruent figures. Remember, congruent figures are the same size. Okay, I'm going to say angles and side lengths. Okay, they have to be the same. They have to equal each other. All right. Rigid motion. Oh, sorry. Same size, same shape. Okay, they can't change shape. Rigid motion. Rigid motion, when transforming, angles and side lengths stay the same. Right, and that is rigid motion previously. All right, here we go, getting into some practice stuff here. Side angle side, congruence theorem. All right, if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle. Remember, included means that angle is in between the two sides. Side, angle, side. Right? In between side, angle, side. Okay, so side, angle, side. Here's again. Side, angle, angle, side. Okay? See why angle is in between, right? It's included, it's in between the two equal sides, or congruent sides. In this example, if AB is congruent to DE, right, which is shown, angle A is congruent to angle D, and AC is congruent to DF, then those two triangles are congruent. Why? Because of side, angle, side. Let's get into some practice here. First practice problem is a proof. Okay, do not let this scare you. We're totally fine. We're okay. What we're trying to prove, well, in this lesson specifically, we're trying to prove side, angle, side. Okay, we're trying to prove side, angle, side. Well, let's start with what we're given, because that's what we should start with, right? With our first given, we know that BD is perpendicular to AC. Okay, why? That's given. All right, and we know that AD is congruent to CD. That is also given. So what does that just say? Well, AD is congruent to DC, right there, right? That is a side. There's a side. Our other given was that we had an angle here. We had an angle. Well, what do we know about BDC? BDC has to equal 90 degrees, which is equal to ABD. So we can say that. We can say that angle ADB is congruent to angle BDC. Why? What you can say is supplementary angles, right? They're supplementary. You can also say linear pair. Linear pair. They're a linear pair and they're 90 degrees. So linear pair perpendicular theorem is what it's actually called. Okay, so there we have an angle. Okay, we have our angle, side angle. So we have side, angle. What's the last thing we need? We have side angle. What's that last S stand for? Stands for S, or stands for side, right? And if we have a side and angle, we need that third side. We need that to be right here. We need that third side right there because our angle has to be included. It has to be inside the two sides. All right? What do we know about that side? Let me erase this so I can see my letter. It's D. Okay? So BD, can't we say that? Can't we say that BD is congruent to BD? And what property is that called? When something equals itself, it's called the reflexive property. Okay. There we go. Now we have a side, an angle, and another side. Therefore, we can prove this. We can say that triangle, I'm going to write down here, triangle ABD is congruent to triangle CBD. Why? Sorry, CBD. Why? Because of side, angle, side. There's our proof. So, with side, angle, side, all we need is two sides congruent with an angle in between the two sides. This one, start with our given. Okay, we know what our given is. 1 JN is congruent to MN. Where is that? JN and MN. Okay, well, hey, there's a side. There's a side. I like to write next to it. I like to say there's a side, just so I can keep track. And what else? We know that NK is congruent to NL. NK is congruent to ML. There's another side. Okay, so we're already off to two sides. That's good. Two sides, check. Now we need an angle in between our sides. Which angle is that? Well, that's right here, right? What do we know about those two angles? I know that they're congruent. Angle JMK is congruent to angle MNL. Why? Because of vertical angles theorem. And I'm okay if you just say vertical angles. I get that. Okay? Here we go. We got our angle. Okay, so we have our side, angle, side. So now what can we say? We can say that triangle JNK is congruent to triangle MNL. Y, side, angle, side. There's our proofs. Let's move on. Number 4. Use given information to name two triangles that are congruent. Explain your reasoning. Okay. Well, we have to explain our reasoning. We could just say, well, that those two triangles are congruent because that's what the question asks. And there's only two triangles congruent, or two triangles there. That's fine. But we have to explain. Okay. What do we know? We know that we have our angle here. Okay. That's important to know. What else do we know? Well, we know that P is the center. Oh, I just crossed it out. I didn't mean to cross it out. That's something. P is the center point. So once you agree that if P is the center point, that this side would be congruent to this side because it's a line, right? And P is right in the middle. That's the definition of a midpoint or center point. Good. Well, if we have our side length and we have those angles the same, if these angles are the same, well then PH and PE have to be congruent. They have to be congruent. So what triangles are congruent? Triangle EPF is congruent to triangle HPG. Yeah, all right. And I talked myself through that. I talked myself, we could write it down. FP is congruent to PG. And then, because of midpoint, yeah. And then because the angle of P is both congruent, or HPG is congruent to EPF, those other two side lengths have to be the same as well. Okay? Which you should write down when explaining. I'm saving time by talking my way through it. You guys should be writing it down. Number 4, ABCDEF is a regular hexagon. What does a regular hexagon mean? All sides are congruent. All sides are equal. It's a regular hexagon. That's important information, okay? Because we know that this side is congruent to that side, which is great to know. Okay. We also know that if it's going in a diagonal or straight across our hexagon from one angle to the other, that side is congruent to that side. What else do we know? Well, we have to find an angle in between, and we have to find a side length. Okay? Let's start with our angle. Our angles B and C. Okay? Well, we have an angle, we have a side, and we have another side, but our sides aren't on opposite sides of the angle. Okay? Or that angle isn't included in our sides. So we can't prove that yet. What we do know well, let's start here. If A goes to C, that's moving 2 vertices to the right. Well, B goes to D, that's 2 vertices, right? And if it's a regular hexagon, we know that B side lengths are equal as well, right? So therefore, we can say triangle ACF is congruent to triangle EBD. There's our final answer. Okay, I will let you guys get to the last one and work on that one on your own. See if you can do it. That will be the end of 5.3. No.